Hello, mic check 1 2. All right. Let's do this again because my last video is not working. So let's see. I love doing stuff twice. It's fun. Alrighty. Let's go over this again. At least practice makes perfect. All right. So this video is going to be a little bit faster, but it's more of like a kind of like a quick review. Because my older video that I put out, like slides don't match, and I don't know. There's something wrong with it. This will be a little bit better. So what do you need to know? Central nervous system, brain and spinal cord. Okay. Need to know that brain and spinal cord that looks like a beautiful both A and B. Know the difference between sensation and perception. Okay. Let me see if this thing's recording just to make sure. Because that's what happened a second ago. Okay, no, well, things are cool. Okay. So sensation versus perception. Okay, and know the brain functions. Again, it's the middle of the homeostasis arc, and it's also the middle part of you just living. Know the difference between central nervous system, which is brain and spinal cord, and the peripheral nervous system. Meninges, coverings of the brain. Know the three coverings: dura, arachnoid, pia. Underneath the dura, which is the toughest layer, dura, durable, epidural space. Arachnoid, web-like. Arachnoid is like, looks like a spider. That's the CSF layer. That's where we get the CSF. And the pia is all the way deep, and that's where? Blood vessels and nerves. And of course, since it's all the way on the inside, it is the most delicate layer. Blood vessels and nerves, pia matter. CSF, arachnoid. Dura, tough outer layer. Picture here, nice to know. I don't even show this picture even for lab. Ventricles, two lateral and a third and a fourth. The lateral is connected by the interventricular foramen here. Number 3 and number 4 are connected with the cerebral aqueduct. The cerebral spinal fluid is all throughout all 4 of these ventricles or rooms, and the fluid is constant. So whatever goes in goes out. This entire blue area is covered by something called the choroid plexus. Where is it? Right here. And the choroid plexus is made out of ependymal cells. Arachnoid granulations are the thing that absorbs the CSF, but know that for our purposes, choroid plexus and ependymal cells, it's a more alpha question. This is a more of a Bravo question. And you'll see the volume at any given time is steady. Remember our definition of hydrostatic pressure, right? So too little cerebral spinal fluid, not a good thing. Too much, dangerous. You can see the corpus callosum here, cingulate gyrus, cerebellum, pons, medulla oblongata. And you could see how the brain coordinates with the rest of the central nervous system, which is the spinal cord. Brain contains centers for doing all of these. We know what? Sensory. We know the difference between sensation and perception. Sensation is what? You feel hot. You feel either heat or you feel cold, zeros or ones. But the perception is, oh my God, that's annoying, or that's painful, or I didn't even feel that at all. Perception is your brain's take on it, you know? Like, for example, sensation. If all of us saw the color red, everyone sees the color red, right? But the perception, right? Maybe you're like a bull and you see red and you want to charge. Or if you see red, like me, you think McDonald's and you're hungry. Motor commands, sensory, coordination of both. And of course, coordination of your visceral stuff. So your GI, your gastrointestinal smooth muscle. And of course, all the perceptions, sensations, everything all comes together is your personality, right? And when you look at your personality, you got to think about it. It's the way you sense things, the way you interpret things, right? Your perception, and the way you act on them. That's your personality, right? Forebrain, midbrain, hindbrain. The cavities, nice to know. Forebrain, midbrain, hindbrain, kind of know, but we're going to be talking about the specific parts. It's better to know, hey, what's the function of cerebrum? Hey, it goes, what's so big about the midbrain, cerebellum, pons, and medulla oblongata. Hindbrain is the connection right before the spinal cord. So these are what the last three. They are very, very vital and they're important. Actually, that's what they're called. They're actually called vital centers. And vida, right? That's life. So anything happens to the hindbrain, it's going to definitely endanger your life. Adult brain has the cerebrum, diencephalon, cerebellum, and brainstem. So let's talk about each one. Cerebrum is the largest part. And what's the cerebrum? It's all this stuff, gray stuff. It's all this stuff. That's your cerebrum. There's a left side and a right side, and that's called your cerebral hemispheres. The corpus callosum that we already know and love, the Nike swoosh right here, connects both the left and right. Gyri and sulci. Sulci are the grooves. So see these little deep lines, these little grooves? That's a sulcus, singular. But a gyrus, singular, is what? The bumps. Sulci and gyri are important because shallowing of either one, diminishment of either one, shows brain damage and also will have significant symptomology. Fissures are even deeper than sulci. You have your longitudinal and your transverse, because the longitudinal separates the cerebral hemispheres. So it's going to go what? The long way, separating left and right. And the transverse is going to go where? It's going to separate the cerebrum from the cerebellum. So your cerebrum is all this up here, and your cerebellum is where? Here. And they call it the arbor vitae. See how it looks like a tree? Tree of life, arbor vitae. Frontal, parietal, occipital, temporal, and your cerebellum. This is your longitudinal fissure. See how it's deeper than the sulci, right? Insula is this area here in between your temporal lobe and your frontal lobe, right? You got to pull it back just a little bit. And your lateral sulcus right here, because it's going what? It's on your side. And then your central sulcus right here. Alrighty. Let's talk about the lobes. Oh, before we do, gray matter doesn't have a lot of fat, therefore it doesn't have a lot of myelin. But the white matter, which is here, right? All these areas here, that has tons of myelin and axons. That means the signals in these areas go a lot faster than the signal in the darker areas. Higher function, of course, is cerebral cortex, right? Movement, memory, reasoning, personality. That's why if you get bonked on the head, in the front of your head especially, you're going to have significant changes in personality. And those of you who are interested in traumatic brain injury, that's this, and this get affected significantly. Sensory association, cerebral cortex, sensory association, motor areas, and they overlap a little bit. And we're going to be talking about the parietal area, and that's where they overlap a little bit. That's why there's going to be a little disclaimer when I start talking about this next part, because some of you are into memorizing. The person who wrote these lectures, they have tons of information and they're trying to condense it. And there's a million and two exceptions to everything that I'm talking about in all of these lectures. But that's for what? That's for further training. So don't dig too deep. Leave it at the level of a 5-week program of what we're talking about here on these slides. And that's also the other impetus for why I'm redoing the video. So there's certain things that are coming up in some of the emails and some of the tutoring that I want to get out to the rest of the group. So I'm going to go back and forth from 19 and 18. The cutaneous sensory area is your parietal lobe. So your parietal lobe is here. All this part right here. Now, you have a sensory area here, right, for your cutaneous, so that's your skin. And then you have your motor area, which is here. Now, the motor area and the sensory area, in the real world, they kind of overlap. The motor area here is part of the frontal, right, because your central sulcus is here. But for our purposes and for the purposes of understanding the parietal lobe is where these two communicate with each other a lot, right? Because remember, when we're looking at the pathway, the homeostatic pathway, you have sensory going up, right? Goes up in here, and then motor going straight back down. So these two are kind of married. And I want you to put these two together because that's what's actually happening in your parietal lobe, not just sensory. It's both, right? You got motor and sensory integrating where? In the parietal lobe, because just like the previous slide, these two kind of, you know, kind of go with each other. So for our class, you're gonna think what? Parietal lobe is the integration of sensory and motor. It's where they talk to each other. Okay. Speech, Wernicke's, right here. If you notice, the Wernicke's area is right next to the temporal area, and the temporal area we learned from the lecture, it has to do with hearing. So if you're hearing speech, right, Wernicke's area is receptive speech. It's how you learn how to speak, right? And it's also how you know the things that well, at least most of the things that are coming out of my mouth in this lecture, right? So Wernicke's, think what? Receptive speech, right? Understanding the language that is being said to you. And that's Wernicke's. Now, Broca's, which they're going to talk about later, and I don't understand why they talk about it later. If you look at Broca's, it's here in the frontal lobe, but it's kind of close to this motor area. So Broca's is what is expressive speech when you want to say something, right? And do you see it's also smack dab in the middle of your judgment. So it makes sense. Motor, judgment. So Broca's is what? When you want to say something. Frontal eye field is also here too, because we're going to learn in a second, the occipital is what? Visual. But your frontal eye field, which is near your motor area, is more about what? Controlling where your eyeballs go. But interpreting what you're seeing, that's where occipital lobe back there. So I hope that clears it up a little bit. I had a couple of questions regarding that. Regarding sensory area for taste, central sulcus in part of the insula. So it's where? It's kind of like here and a little bit here. So that's a nice Bravo question. Insula, part of the central sulcus. Didn't really focus it on it in lecture. Deep temporal lobes. Sensory, I kind of brushed off on the lecture, but if you see, this is temporal lobe, so is hearing, right? Temporal lobe. So put them together because that looks like a nice both A and B. But the second you see hearing, you're gonna definitely think what? You think hearing, you're gonna definitely think temporal lobe. Big on hearing because it's right there, right next to your ear. Frontal, parietal. So this parietal lobe association areas, understanding speech, choosing words to express thoughts and feelings, cross this out. This is true. The person who wrote this isn't lying, but I only have 5 weeks with you. I don't have time to tell you why. It's a little bit more complex than that. So, but definitely the parietal lobe is, I want you to associate for this exam, coordination of what? The motor and the sensory, just right here. Auditory, sensory, we already went over that. Temporal lobe, we already went over that. Now, temporal lobe, right? Interpret complex sensory experiences, understanding speech, reading, right? We already had that. You could write here in your notes, that's Wernicke's, right? Stores memory. Now, this might mess you up Because some of you are like, but it said visual. Cross that out. Just cross it out. I want you to think temporal lobe, things you hear, right? And isn't speech complex patterns, right? So, yes, there's some truth to this, but I want you to think, cross this out. Visual will always be what? Interpretation of visual is where? In the back of your head, occipital. And visual images, right? And of course, insula. There's another one. Yes, it's true. Insula has some emotional response and translating information, but I want you, insula is a nice Bravo question. What do I want you to associate emotion with? I want you, so cross this out, and right next to anything word that's emotional, I want you to write limbic system. Limbic, limbic, limbic. Okay? Limbic. Right? Primary motor area, we already saw there was. Yes, it's in the frontal lobe, but remember, it shares a lot of space with the sensory and the parietal lobe. So if I ask you, where is the primary motor area? You'll say frontal lobe, but where is the association where the motor and sensory work together? That's parietal lobe. Broca's area, we already talked about. Frontal eye field, we already talked about. Dominant and non-dominant hemisphere. If you're right-handed, like most people are, your dominant hemisphere will be your left side. That's your math side, or that's your analytical side. Verbal, speech, writing. Think about what? Everything you do at school. So if you're right-handed, everything you do at school is what? Left side of your brain. Now, if you're right-handed, your non-dominant or your more artistic side is on your right side of your brain. So right-handed, dominant hemisphere would be your left hemisphere. If you're right-handed, non-dominant hemisphere will be your right side. Dominant hemisphere, think what? Things that you do, academic things, right? And non-dominant is think art, all the artistic things, music, singing, visual patterns. And actually, because of the corpus callosum, these two blend in. Why do you think kids who are really good at music and art, like painting, right? They're really good at reading and writing, right? Um, um, and again, you don't have to be good at it. I know I'm being recorded, but my eldest, Chanel, not the best dancer in the world, but her dancing and keeping up with rhythm and time helped her what? Helped her learn English, right? To the point where she now has an English accent. It's kind of creepy. All of these, very important, part of the diencephalon, right? Nice. But what's better? Knowing the exact parts. So thalamus, I want you to think gateway or sensory impulse. Okay. It is one of the two places where we have to filter out everything except for smell, right? Because remember, if you take in everything all at once, it's hard to do, it's hard to concentrate. Just imagine if you saw every piece of light and listened to every piece of sound in the room. You'll go nuts. Hypothalamus, think homeostasis, H and H. And these are everything that has to stay stable. Your heart rate, blood pressure, body temperature, water and electrolyte balance. Even hunger. You can't be hungry all the time. Even though us diabetics in the room, it's hard, right? But all of this is what? A nice little cycle. Oh, looky here, sleep and wakefulness. That means when you're sleeping in my class, it's not because I'm boring. Well, maybe a little bit. But he goes, you're not getting enough sleep. And of course, you're also not doing what I told you first day, active listening, right? You can turn your brain off a little bit, but you look for what? The key words. So you see hypothalamus, homeostasis. You see thalamus, you see gateway for sensory. Why do I have a lisp? Limbic system, big, big, big on what? Feelings, emotions. All right, just leave it at that. Okay. Next, brainstem. So all the stuff that we just talked about, that's the diencephalon. So you put that in your diencephalon box. Now the brainstem, remember midbrain pons and medulla oblongata was really deep inside the brain, almost to the level of the spinal cord. Therefore, it's crazy important. Anything goes down in midbrain pons or medulla oblongata, especially the medulla oblongata, you're going to have a lot of trouble. Picture, don't have to worry. You're not going to medical school, but here you need to know your cerebral aqueduct, we already know. Your cerebral peduncles, right? And where are they? They're here, right? Your cerebral peduncles, I want you to think motor, right? Corpora quadrigemina. Quad means four. You got two eyes, two ears. The corpora quadrigemina is visual and auditory reflexes. And your red nucleus, you're going to think what? Postural reflexes. So right now you're sitting up. You're not thinking about sitting up, or you're standing up, or you're driving, or whatever. You're not thinking really. Because remember, reflex do not require the brain. Pons. Big thing about pons, regulation of breathing. So your breathing should sound like this. Inhale, exhale. Inhale, exhale. Right? Pons does that. If your pons isn't working, it'll be all over the place. Then you won't be able to breathe. Your medulla oblongata, two sets of it. One part has your vital centers. So it's your cardiac, vasomotor, which is your blood pressure, and respiratory. Right? You could see if something goes down there, you're going to be dead. But the non-vital, that's coughing, sneezing, swallowing, and vomiting. And swallowing and vomiting are opposites of each other. So all of this is the medulla oblongata. Okay, I could ask you about the vital centers, and then I could ask you about the non-vital. Anything happens to the medulla oblongata, odds are it's going to hit the vital center, and you will be dead. Reticular activating system, think what? Wakefulness. So I increase RAS, you increase what? Wakefulness. Some of you have decreased RAS. And again, it could be partially my lecture. I'll admit it. Gets boring every once in a while, but got to get some sleep. Activate your RAS. Now, your RAS is called a reticular formation, right? And remember, your reticular, something that's reticular, it's going to also be like a sieve or some sort of filter. Therefore, this is the second place where your body filters incoming sensory. So this, along with your thalamus, it figures out what's important, what's not important, because you don't need to know everything. And that's what I'm doing with this video here. Do you have to take in everything, every little word in this PowerPoint, every little word in the textbook? No, right? Filter some of this because it's killing some of you grade-wise. You guys are thinking too deeply. Non-rapid sleep, that's what? The three stages. It goes, you're tired, right? Decreasing activity of your RAS, right? But there are no dreams. You have gonna have a reduced blood pressure and reduced respiratory rate, and that makes sense. You're about to go to sleep, right? So your rapid eye movement is when you're definitely asleep, and it's called you're definitely asleep. Your eyeballs are moving inside your underneath your eyelids, but you are gone. You have you're hypotonic. You don't have a lot of tone in your body, and you go through something called paradoxical sleep. You would think that your brain is also asleep, just like your body, but your brain is very active, and that's why you have dreams, because you start thinking. Your brain, when you sleep, it starts organizing things, right? And some of it goes through your visual sensors, and some of it goes through all these other things. That's why some of your dreams seem so real. Because remember, what makes you feel reality? It's your brain. Cerebellum. The cerebellum is that area. I don't want to go all the way back. Underneath your so if you look here, let's get a better picture. There you go. So you look here, this is your cerebral cortex, your cerebrum. But your cerebellum is this thing right underneath there. And here's your pons, and here's your medulla oblongata. But right here, that's your cerebellum. What does it do? Well, it's also known as the arbor vitae, because if you slice it in the middle, it forms like a tree. And arbor means tree. its big thing is, like I mentioned in class, posture. And of course, your posture deals with your skeletal muscle activity. So these things also work together. Another thing that the cerebellum does is it makes your movements like fluid. Okay, right? So so it coordinates a lot with sensory, and you can see here it has a lot of coordination parts. But just know that the way you move, like the fluidity of your movement and also your posture, is also controlled by the arbor vitae, which is called your cerebellum. Spinal cord is central nervous system. Spinal nerves is peripheral nervous system. Okay, this is your central nervous system, brain, spinal cord. But this, where is it? Where are you? Oh, ah, boy. Let me show you. So when I'm looking at, here you go. When I'm looking at this is your spinal cord. That's central nervous system. But see all of these other nerves coming out, right? Radial nerve, medial, ulnar, all of these, right? These are all your spinal nerves. They're part of your peripheral nervous system. I cut spinal nerves, you will become paralyzed, but you will not die. But if I cut I cut anything in your central nervous system, you get real close to death real fast, right? So I cut you here, it's no bueno. I cut you here, it's still bad, but you will live. The odds of you living get really, really low. I don't know why they didn't put. Okay. So spinal nerves, think what? Peripheral nervous system. Monosynaptic reflex, that's your patellar knee jerk. Monosynaptic means what? It's only one. One thing I got to go deal with, right? But the withdrawal reflex, remember we talked about being scared? So many things happen when you're being scared, and it's polysynaptic. That means sensory, interneuron, motor neuron, all the reflexes, all the parts of the reflexes are on fire when you're scared. And that's a withdrawal reflex, because remember what reflexes are. They're there to protect you. Reciprocal innervation, that's when especially in the withdrawal reflex. Remember I told you when I got my hand burned by the oil of the fish I was cooking, right? The flexors have to contract, but the extensors have to relax, and vice versa. Um, you can't have everything contracting. Some things have to be relaxed, and that's called reciprocal innervation. And that's part of this polysynaptic innervation that's going on in your withdrawal reflex. So you think a stretch reflex like a knee jerk, monosynaptic, very simple. But the withdrawal reflex, very complicated, right? So you could see here. And remember the big thing that we learned, right? In lecture, the sensory goes where? In the back of the spinal cord. So sensory is posterior, right? And or dorsal, and the motor comes out the front, anterior or ventral. So some neurologists will say dorsal pathway, you're going to think what? Sensory. And ventral pathway, you're going to think motor. Okay? And you could see here, there's an interneuron on this reflex. And and don't memorize this, right? Like let's say I'm doing withdrawal reflex, it's going to test what? L5, S1, S2, right? So if they can't do this, what are we now going to investigate? I'm going to start investigating nerves L5, S1, S2. I'm going to start looking at this patient's lumbar and sacral vertebrae. Crossed extensor reflex. The biggest thing you need to know is what? Ipsilateral is what? Same side, right? It goes, and contralateral is the exact opposite. So contra means the exact opposite, right? Because That's what has to happen. It goes in a withdrawal reflex or a cross extensor reflex, is that it shifts it shifts the body weight. So one side's going to be active, the ipsilateral side, right? And the other side will be what? Will do the exact opposite thing. Because when you're walking, you're not doing the same exact thing on both left and right side. Just know ipsilateral is what? Same side. Contra, opposite side. That's a nice medical term for next exam in lab. And you could see here, in order for you to walk, in order for you to withdraw from something, one side's going to be what? Stimulated or contracting, and the other side is going to be what? Inhibiting. And we already know that from this term here, reciprocal innervation. And we also know that from my taser story. If you get tased, are you going anywhere? You can't withdraw, you can't advance. And that's why it's a lovely non-lethal. Peripheral nervous system, cranial and spinal nerves. They are not part of the central nervous system. Somatic versus autonomic. Somatic, you're going to think skeletal muscles. Autonomic, you're going to think um, uh, sympathetic versus parasympathetic. Remember, we talked about the different drugs. Remember, we talked about fight or flight, which is sympathetic nervous system, increased heart rate, increased blood pressure, and your pupils will dilate if you're what? Scared or if you're in a fight. Endoneurium, perineurium, epineurium. I don't know why they put this in the wrong order, but the what do you call that? The perineurium. I hate looking at this. This is confusing me. But if you want to use your medical terminology powers, endo's got to be the coverings on the very inside. So it's going to cover what? Axons. And then the perineurium is going to be the one on the very, very outside, which is going to um, uh, wait, now I'm getting it backwards. Endoneurium, think all the way on the inside. Epineurium, right on top of a group of fascicles, but on a separate fascicle, that's the perineurium. Now that I've confused you totally, just know that endo, think what? Axon. Perineurium, single fascicle. Epineurium, a group of fascicles. Now, let's follow this. I believe this is a little bit better in my opinion. Let's zoom in. Right? So the epineurium is where? Epi, right on top of everything, right? So that's everything. And the fascicle here, the separate fascicle, is going to be perineurium, right? And then the endoneurium is the singular axon. Okay? So you could look at it that way. And this is slide 44, if you're a visual person. Slide 43, if you're doing keywords. Next. Sensory motor mixed. It's the categories that you have to know about your cranial nerves. Your best bet. Start looking at slide 48, 49. You have to know the Roman numeral. You have to know the name, whether it is sensory, motor, or both, which is mixed here. And then, of course, just a little bit of function. Example, my patient can't smell a thing. Which cranial nerve? Cranial nerve, Roman numeral 1. It goes, what's cranial nerve Roman numeral 1 called? Olfactory. What's the function of olfactory? It goes to smell. Is it sensory, motor, or both? It's sensory only. That's what you should be able to do. All the flashcard people in the room, this is a nice thing to make. Your spinal nerves, 31 pairs, right? And the weird one is cervical nerves, C1 to C8. You have 7 cervical vertebrae, but you have 8 cervical nerves. And remember, your sacrum, you only have 1 sacrum, but it used to be 5 fused bones. So it's S1 through S5. And your coccygeal is called CO, with a little o, and that is your nerve at the very end. It forms a descending root of lumbar, sacral, and coccygeal nerves that make a nice little like horse's tail. hence the term cauda equina. All of these nerves are connected to your skin, innervations to your skin for sensory, and those are called dermatomes, which is this thing right here. Remember the story I told you about Mr. Kawasaki, ninja motorcycle guy, severed his S2, S3, R4, so he can no longer use this, and he could no longer use this part. Autonomic nervous system, we already talked about that. Homeostasis, response to stress, because we're talking about increased heart rate. So sympathetic, think fight or flight. Increased heart rate, increased blood pressure, and dilation of your pupils. Parasympathetic, the exact opposite. Decreased blood pressure, decreased respiratory rate, and what? Constriction of the pupils. Rest and digest, and that's why if you do a drug that's parasympathetic, you're going to get the munchies. But if you do a sympathomimetic drug like cocaine or crack cocaine, you're going to be ready to fight everyone and or run away from everyone right after you start said fight. And lifestyle changes, everything goes downhill, then you die. Alrighty, that's it. If I went a little bit too fast, it's okay. You can play me at quarter speed. You know how YouTube works, so I hope this works. I'll see you when I see you. Bye.